All right. Cool. Okay. All right. Cool. Now we are recording. Okay. So this is the new topic of the class, polynomial functions. If you are a person who likes to write down notes, write these as a big title, polynomial functions, right? So let's begin with something that with the easiest part. Now, I know a lot of you forget about what are polynomials, and if you look at these definition of what are polynomials, you are going to be completely lost, right? Because I don't know what is this a n x n minus one and just look. This looks awful, right? So I decided to teach it to you in a different way. Look, we are familiar with some other polynomial functions, right? So for example, we know these functions, the quadratic function, the cubic function, the quartic function. We know these ones, right? Let's begin with what is a polynomial function, or what is a polynomial instead. All right, a polynomial is a mix of different monomials. Do you guys remember that? Expressions can be said they are monomials or binomials or trinomials or polynomials. Do you remember that? You guys saw it in I don't know, maybe sixth grade, right? Take a look at this one. The one that I have here, it is a binomial, right? Now, how do I know this is a binomial? Okay, because this has two monomials, right? Two expressions separated by a plus or a minus. This is one of those expressions, and this is the other one. So since we have two, we call this a binomial. Now this one here, this is a trinomial, right? A trinomial, because we have three expressions separated by a plus or a minus, right? Cool. Now, also, we also know that polynomials have a degree. Polynomials have a degree. So for example, the first one, what is the degree of the first one? Now, in case you don't remember, to find the degree, all you have to do is take a look at the biggest exponent of the function. So the biggest exponent of this function is 1, right? Because it's right there, x to the 1. This is x to the 1. So this function has a degree of 1, right? The name of the function is linear because we have studied this type of function. This is one of the functions that we have studied in the past. In the first term, we studied this type of functions, right? This is y equals mx plus c. This is a linear function. This value is the slope, and the second value is the y-intercept. We have studied these type of functions. All right. The second one, can you tell me what is the degree of the second function, please? Anybody? Thank you,
Two.
Richie. Now, y
Two.
is 2.
Because the greatest exponent in that equation is the x to the second power.
Richie, you are correct as usually. Thank you, brother. Yes, to find the degree, all we have to do is take a look at the biggest exponent in the variables. So here we have no variable. Here we have one variable with the exponent 1. And here we have the same variable with the exponent 2. That is the biggest exponent. So the degree is 2. How do we call this type of functions? We have studied
Quadratic.
this type of functions, right?
Quadratic.
Richie, you are correct.
Quadratic.
This is a quadratic function. This is a quadratic function. Again, we studied this term, I believe. I think it was what, before the break? Maybe before the break, right? And we can do things from this function. We can find the solutions, or we can find the intercepts. We can find the vertex. Remember all of that? We know if these functions open up or down according to the value a. We know all of that, right? We know all of that. Okay, let's go with the third one, the degree of the third one. Now, think about it. Think about it. Don't just say it to me, because I think this is pretty simple, right? Think about
Three.
it. Or you can say it to me. Okay, thank you, Richie. The degree is 3. The degree is 3. Why? Again, because the biggest exponent that we find in the variables is 3. So the degree of this polynomial function is 3. How do you call this type of function? This is a cubic function. That is the name. This is a cubic function. Let's go with the last one. What is the degree of this one? It's pretty simple now, right? 4.
4.
Again, the biggest exponent on the variables right there, 4. So the degree is 4. The name of the function, quartic. Quartic functions. Now, are these the only polynomial functions? Of course not. We can have functions of degree 5. So we will have ax to the 5 plus bx to the 4 plus cx to the 3 and all of that, right? Degree 6, degree 7, degree 1000. We can have an infinite amount of polynomial functions. Only that these 4 are the ones that we use the most. So if you want to get really, really good at math, you study all of the polynomial functions. But if you want to get kind of good at math, you study these 4. All right? Cool. Couple of things, though. Take a look at this. Take a look at this. The degree of a polynomial function is the largest power of x that appears, right? The largest power of x that appears. But that number, that largest power of x, so the exponent, has one condition. That exponent has to be a natural number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all of those natural numbers. If we have a negative number, for example, negative 1, negative 2, negative 3, negative 4, all of those, then those are not natural numbers. Those are integer numbers. And those exponents are not the degree of the polynomial. In fact, if we have a function that has a negative exponent, that function is not a polynomial. If we have a function that has an exponent that is a fraction, then that function is not a polynomial. All right, take a look at this. We did all of this already. All right, let's begin with this simple example. Identifying polynomial functions. Let's identify if these 6 functions are polynomials or not. And if they are, we are going to identify the degree. So let's begin with the first one. Is this a polynomial function or not? Okay, yes, it is a polynomial function. How do we know? Well, because we have 2 monomials separated by a plus or a minus. And we know the degree is 4 because the biggest exponent on the variables is a 4. It's a 4. So the degree is 4. All right, pretty simple. How about B? How about B? Is B a polynomial function? Is B a polynomial function or not? Go ahead and write it in the chat, please. Write it in the chat. Don't be afraid. I am not going to read your answers as usual. Just say yes or say no. You don't even have to tell me why if you don't want to. I'm going to explain it in a second, all right? Say yes or say no. If you say yes, of course, you have to tell me what is the degree, right? Okay, we have 13 people now writing the answers. Thank you. Now, we have 24 people in the chat. 24 people in my class. 24. So, guys, I want everybody to please answer the question. I know Valdebello is having difficulties. So, Vale, you are okay if you don't answer, all right? You are okay if you don't answer. But everybody else, guys, everybody else needs to answer.
Pero se trabó un poquito. ¿Puedes repetirlo? Se trabó.
Vale, dije que está bien si no respondes. No pasa nada porque sé que tienes problemas de internet. ¿Mejor?
Ah, ok. Gracias, profe.
Con gusto, mi niña, con gusto. All right, let's continue. So, let's take a look at this. Is G a polynomial function? No, G is not a polynomial function. And you will say, but why, teacher? Simple. Because of the root. Look, take a look at this. We know that roots can be expressed as exponents, right? So this is a fraction. That exponent is a fraction, 1 over 2. And we need to have every exponent as natural numbers. Natural numbers. So, simply because of the root, this is not a polynomial function. All right, let's go with C. Tell me in the chat, please, is C, so the function h, Is that function a polynomial, yes or no? Again, if you say yes, you're going to have to write down the degree. Think about it, give it a minute, think about it, and you can tell me in the chat, please. Nobody?
Wait a second, wait a second.
All right. Okay, we have 5 answers now. All right. Okay, thank you. Listen, again, I am not reading answers, right? I just want you to think about it, to try it. So go ahead and think about it and write down your answer. Tell me what you think. Tell me what you think. Right? If it is right, congratulations. If it is wrong, then it's okay. You'll learn something new, right? You'll learn something new. Okay, we have 11 people. What is going on with the rest, guys? What is going on with the rest? All right, let's see who is not answering. Okay, let's see. Carlitos, you're not answering, brother. Ethan, you are not answering. Jesus, you are not answering. Everybody, guys, everybody, please answer the question. Even if you are wrong, think about it, decide, and answer it. All right, cool. Now we have enough answers, so we can continue. All right, so let's see. Is this a polynomial function or not? Let's take a look. H is not a polynomial function. Why? Simple. Because this function is a fraction. This function is the ratio of 2 distinct polynomials. We have a polynomial on top and we have a polynomial down. But remember, in order for a function to be a polynomial, we need to have every expression separated by a plus or a minus. And in this case, we have this expression separated by this by a division. So multiplications and divisions does not count. Those two do not count for polynomial functions. All right? Beautiful. So now we know. Now we know this is not a polynomial function. All right? This is, in fact, a rational function. Why is this a rational function? Because this is a ratio, right? Fractions are ratios. So this is a rational function. We'll see that on the next class. Next class, we're going to move our attention to these types of functions. All right. How about question D? Is that one, question D, a polynomial function or not? In the chat, please. Again, everybody. Everybody. Again, everybody in the chat. You can say yes, you can say no. And remember, if you say yes, you also have to tell me the degree of the function. Right? You can say no, and that is it. But if you say yes, you have to tell me the degree, all right? Okay, now we have some degrees. All right, beautiful, beautiful. All right, let's take a look at this. So, question D. F is the zero polynomial function. All right, take a look at this. This is, in fact, a polynomial function because it has one, just even one monomial, 0. So that makes it a polynomial function. So the people who said, yes, you are correct. Beautiful. But about the degree, let's take a look at the degree of the function. This function does not have a degree. This function does not have a degree. It is not assigned a degree. So in the future, guys, in the future, if you see the number 0 alone, you know that that number is a polynomial, but the degree is undefined or not solution or not degree or something like that. Okay? Now, it is different For this one, for the question E, is different. Question E is a polynomial function as well as this one, right? These two are polynomial functions, these two, D and E. But this function do have a degree. This one does have a degree. What is the degree? The degree is 0. Why? Because remember that we're looking for the biggest exponent on the variable, and we don't have a variable here. Right? So we can say that this is the original function, a times x to the 0. Do you guys remember how much is any number to the 0? We saw this, right? Thank you, Sarah. We saw this in the review. Any number to the 0 is equal to 1. So what I have in here is 8 times 1. That is what I have there, 8 times 1, which is just 8. Did you see? By multiplying the 8 by x to the 0, I have not changed the value 8. But now we can see that the degree is 0, right? So please write this down somewhere, because I think I'm going to ask it to you during the next quiz. 0 does not have a degree, but any other number different than 0 have a degree, and that degree is 0. Okay, guys? Cool. To end this exercise, tell me the question F. Is this a polynomial or not? In the chat, please, everybody. Again, if you say yes, you're gonna have to write down the degree, right? If you say yes, you're gonna have to write down the degree. Everybody, please, everybody. One, two, three, four, five, 6, 7. We only have 7 answers so far. Think about the question and answer it, guys. Please don't just stay there doing nothing. That is not how you're going to learn math. You learn math by thinking and telling me the answer. It's okay. It is okay if you are wrong. It is okay if you are wrong. Okay, let's take a look. I believe that so far, I have given you enough time to answer the question, right? So if you have not answered the question, you're going to have a -1. So a -1 in today's classwork. In other words, if you were to have a 7, now you have a 6. Let's see who hasn't answered. Look at that. Look at that. Juan David Ferran, Juan Diego Rojas, Santiago Pavón, Maria Paz. The moment I say I'm going to give you a negative note, that is the moment you answer. You see? You see how I have to help you understand? Guys, I don't want to do that. I don't want to be the bad guy. Just answer the question, all right? Just answer it. Think about it and answer it. All right, let's take a look. So, just like I said on the question C, polynomials have to be separated by additions or subtractions, not divisions or multiplications. So what you have in here is a multiplication. So you might be saying, all right, then this is not a polynomial. This is not a polynomial. But guess what? Guess what? Guess what? This polynomial can be expanded. We can solve this multiplication. In this case, in the question C, we couldn't expand this function. We couldn't do the division. We couldn't. But in this one, we can. In this one, we can. So if we expand this multiplication, first, we're going to begin by expanding the binomial, right? We had a binomial to the second power. So this is a notable product. ¿Se acuerdan por allá en octavo cuando con Laura les explicó qué eran los productos notables y cómo se expandía esto? Bueno, pues así se expande, ¿no? Queda de esta manera. From here, we can do the distributive property, right? And if we do the distributive property, we have this times x squared, with this times negative 2x, and this times 1. If we do that multiplication, we have this. And now look at that. We have a polynomial because every single expression, every single monomial is being separated by a plus or a minus. And the biggest exponent is 5. So h is a polynomial function of degree 5. Congratulations to the people who said yes. Not so many congratulations to the people who copied from Sarah or somebody else. All right. Let's jump into this. Next type of questions. Some other, all right. In some questions, I'm going to ask you to identify a polynomial or not. All right. In some questions, I am going to have to ask you to tell me if a function is a polynomial or not. But there are some other questions where I'm going to ask you about the zeros of a function. Now, we all know, because we see it from the review, that zeros are solutions of a function, right? Hace un momentico al español. ¿Cómo así ceros, profe? No entiendo. Ay, mira, aquí no hay ningún cero. Mira, aquí esto es una X, esto es un 1, un 2, una X, un 3. Aquí no hay, mira, aquí hay una F. Aquí no hay ningún cero. ¿Cómo así? No, pues no hay ningún cero. No, un cero no es el numerito. El cero de una función no es el numerito. El cero de una función son las soluciones de esa función. ¿Ok? Y esas sabemos cómo encontrarlas. Al menos las de x a la 1 y x a la 2. Las sabemos encontrar. Las lineales y las cuadráticas. Estas de aquí, pues no sabemos tanto. No sabemos en realidad cómo se hace. Pero ya mismo les muestro. Pay close attention, guys. Step 1. This is how you find the zeros of a solution. Number 1. Take the solution. Take the function and change this sign in here. Change this f of x. Change it by 0. Look at that. That is step 1. Changing the f of x by a 0. Step 1, done. Step 2, now that we have a multiplication here, look at this. We have x minus 1 squared, multiply it by x plus 3, right? We have parentheses, so this is a multiplication, right? So we have two values that are being multiplied equal to 0. So we can split these two like this. Boop. The first factor, again, remember, factor is a fancy word for multiplication. ¿Sí? Entonces, aquí cuando yo hablo de factores, quiero decir el numerito que está multiplicando. Entonces, aquí como tengo dos numeritos multiplicándose, pues tengo dos factores. Este factor y este factor. Eso es lo que significa la palabra factor. All right, so take a look at this. The first factor equal to 0 on one side, and the second factor equal to 0 on the other side. We did this when we were studying how to solve quadratic functions. Did you guys remember this? Hopefully you know. All right, I see Lunita knows. I see Juan Parrado knows. All right, cool. All right, so what do we do from here? Okay, from here, we are going to solve each function individually. Because look, here we have one function, one equation, and here we have another equation. But we know how to solve these two equations. Of course, some of you might be thinking, teacher, I don't remember how to solve this. Look, it's pretty simple. All you have to do is pass the exponent to the other side as a root. That is what we're doing, right? We are isolating the value x. To isolate the value, all we have to do is move everything else to the other side. Of course, with the opposite operation. So the opposite operation of exponent is going to be root. So here I have the square root of 0. How much is that, guys? How much is that? How much is the square root of 0? Thank you, Sarita Galvis. Carlos, thank you. Richie, all right. All right, I'm assuming The rest of you have no idea. So,
Zero.
thank you, Parrao. How do we know? Simple. Because we are looking for a number that multiplied by itself gives us 0. What is the only number that when you multiply by itself gives you a 0? Well, 0. So the square root of 0 is 0 again. Look at that. Now we took out this exponent. And from here, the step is pretty simple, right? The negative 1, we're going to move it to the other side as positive 1, right? So we have 1 equals x. Look at that. We have one of the solutions. That is what we're looking for, right? Look at this. Look at the question. We are finding the zeros. So solutions of the function, right? This is the first solution. This is the first 0. Lo digo otra vez en españolito. Pero, profe, eso no es un 0. ¿Cómo así? Mire, eso claramente es un 1. ¿Cómo así que es un 0? No, señor. Es que, mis niños, cuando buscamos los ceros de una función, llamamos ceros a las soluciones. Y esta es una solución. Así que esto es un 0. Es un 1, sí, pero no estoy hablando que es el 0 el número. Estoy hablando que es el 0 la solución. Eso les va a pasar hasta, mira, hasta en la prueba Saber 9, si en serio la hacen este año, que no creo, pero si de pronto, pues les preguntarán, encuentre el 0. Y no es buscar dónde está el número 0, es buscar dónde está la solución. ¿Ok? All right, so let's take a look at the second function. Remember, we split these two into two equations, right? So we want to take a look at this one second. How do we isolate x from here? Well, this one is pretty simple because all we have to do is move the 3, which is adding, to subtract. So we have negative 3 equals x. This one was a lot simpler. This one was a lot easier. But look, now we have our two solutions, our two zeros. So the zeros of the function are 1 and negative 3. Huh? How about that? But again, because we did the review with the Kahoot game, remember the Kahoot game? I asked you in one of those questions of the Kahoot, I asked you what were the other names for zeros. So zeros are solutions and are also the x-intercepts. These are the 3 names for the same thing. Zeros can also be called solutions, which can also be called x-intercepts. Write it down somewhere, guys, because in today's exercise or the next class's quiz, I will ask you to find one of these. But you guys, if you don't know the names, you guys are going to forget, right? Sarita, you are correct. I forgot about that one. Roots is another name. We have 4 names for the same thing. 4 names for the same thing. Zeros, solutions, x-intercepts, and roots. Ceros, soluciones, interceptos en x y raíces. Those are the 4 names, right? Go ahead and write them down somewhere. Guys, you're going to forget. When the quiz comes, you're going to say, teacher, what is this? What is the, find the solution? I don't understand. Find the root. I don't understand. And I'm going to be like this. All right, let's continue. So we know these are the zeros, right? 1 and negative 3. But since these are also the x-intercepts, we can plot this in a function. Look, this is the graph. This is the graph of the function f. This is the graph. I used GeoGebra to plot this function, right? To graph it. Now, we are saying that these are the zeros, which are also the x-intercepts. And we can see those right there. Look, the first one, number 1, is right there. This is one of the roots, one of the x-intercepts. It is right in the middle of 0 and 2. This is the number 1. Remember, x-intercepts are the points of the function, the points that the function touches the x-axis. So right there, right there, there is one solution, 1, 0, 1 x-intercept, 1 root. And where is the other one? Well, in negative 3, look at that. And it is right there. We can see it. It is right there. How beautiful is this? Huh? How beautiful is this? Right in the middle of -2 and -4. How beautiful is this? All right, let's take a look at another example. Example number 2. Example number 2. Find the zeros, so solutions, of this polynomial function. Now, you can do this yourself if that is what you want to do. You can do this yourselves if that is what you want to do. But I'm going to show it to you real quick. Step number 1, take the function and replace the f of x by a 0. That is step number 1. Guys, hopefully you are writing down these steps, right? Because I'm going to ask you to do a lot of this today. I'm going to ask you to do a lot of this today. So replace the first one by 0. From here, we can split these multiplications individually. How many multiplications do we have here? All right. So we have one multiplication there. This is x multiplied by this, right? So we have one multiplication, right? We have x times something. This will be the second multiplication, and this will be the third one, right? So we have 3 factors. We have 3 factors. And we can split them, right, like this. We can split them like this. The first x equal to 0. The second, 2x plus 1 squared equal to 0. And the third one, 3x minus 1 equal to 0. Look, we had 3 factors, so we split it in 3 ways. In today's classwork, guys, maybe you have a function that have 6 factors. Well, don't get scared. Simply split the function in 6. Each factor individually. That is it, guys. That is it. All right, now how do we solve this? Simple. We're going to find the values of x in each on every one of these functions. But look at this. We are really lucky because the first one is already solved. We don't have to do anything here. The value of x is already isolated. We don't have to do anything there, right? We don't. We know already from this, we know that 0 is one of the solutions. 0 is one of the zeros. Let's try to find the other zeros. So let's take the second function, all right? The second equation, sorry. To isolate x, I am going to move everything else to the other side. So we're going to do the same process. The exponent, move it to the other side as a root. So we have the square root of 0. But we know that one, right? The square root of 0 is 0. We know that one. From here, let's move everything else. So the plus 1, we move it to the other side as negative, so -1. But now we have a 2 as a multiplication. What do we do with this? Okay, we move it to the other side, again, with the opposite operation. So the 2, which is multiplying, we're going to move it to divide. And look at that. We have our second solution, our second 0, -1/2. This goes to show, guys, that solutions don't always have to be natural numbers or integer numbers. Solutions can be fractions. Solutions can also be decimals or that sort of things, right? Don't get scared if sometimes a solution gives you something weird. No, just trust on your mathematics, all right? And last but not least, the final equation. How do we isolate this number in here? Again, the same process. The -1 is subtracting. We're going to pass it as positive, right? Then the 3, which is multiplying, we're going to pass it to divide. And just like Carlitos said in the chat, oh, no. Carlitos said, yeah, now Carlitos has it right. All right, Carlos, pretty good. Just like Carlitos and Lou did it in the chat, these are going to be our 3 solutions. Thank you guys for participating. You guys are the best. All right. So we know our 3 solutions, right? We know our 3 solutions. 0, -1/2, and +1/3, right? Again, we know that zeros can also be x-intercepts. So if we put this in a function, again, all I did was I wrote down this function using GeoGebra, right? I wrote down this function using GeoGebra, right? So this is the piece of the function that I took out from there. And we can see there are exactly 1, 2, and 3 x-intercepts, right? Look at that. We had 3 zeros. In fact, the first 0 is this one over there. 0. The second 0 is this one over here, negative 0.5. Why? Well, because negative 1/2 is negative 0.5. And the last one, 1/3, is that one over there. This is 0.33333333333, which is this one over here. Look at that. How beautiful is that? How beautiful is that, guys? All right. So now we know how to find zeros of a function, right? I give you the function and you give me the zeros. But what happens if, take a look at this question. What happens if I give you the zeros and you need to give me the function? So working backwards. That is correct, Emma. By the way, guys, a lot of you had your cameras on, and now you don't. So please turn on your cameras, guys. I'm talking to Pipe, Ethan, Lu, Maria Andrea, Juan Diego, Maria Paz, Majo Fonegra, Sophie Gonzalez. A lot of people had the cameras on, and now you don't have the camera on. Don't turn it off, please. Don't turn it off. The only reason you're turning it off is because you are watching my class from the cell phone. That is understandable. All right, let's continue. Richie, to answer your question, Richie asks in the chat, profe, ¿y tenemos que ponerlo siempre en fracción? I think you're talking about this, right? Zeros, right? No, Richie. Okay, thank you. No, Richie, you don't.
Yes.
Right? If you wanted, you can change this into decimals. That is okay. That is correct. So I could have written this as 0, negative 0.5 and 0.323. That is another option, Richie. Okay, cool. All right, let's jump into the next question. This is another type of exercise. Again, today you guys are going to practice also with these type of questions. Finding a polynomial function from its zeros. I'm going to give you the zeros and you need to tell me the function. So what do we do from here? Take a look at these, guys, please. Stop writing, and take a look at the screen because you are going to get lost, Maria Paz. You are going to get lost, all right? Here it goes. Take a look at this. If negative 3 is a 0 of the function, so this one, if negative 3 is a 0 of the function, then we know x plus 3 has to be a factor of the function. What? Mira, en españolito para que no se me pierdan. Les estoy dando negativo 3 como uno de los ceros. O sea, una solución. El hecho de que negativo 3 sea una solución, pues significa que x más 3, mira, con el signo inverso, x más 3, tiene que ser un factor. ¿Por qué, profe? Well, because of this. Because if this is a factor, and we are going to isolate x, we pass the positive 3 to the other side, and look at that. Now we have it as a solution, as a 0. Huh? So now we can find factors of functions. Now we can find factors of functions. Look, in general, if r is one of the solutions of the function, so a 0 of the function, then x minus r is a factor. So from here we have 3 zeros. We know then the 3 factors. The first factor is x plus 3. In other words, change the value of the 0, change the sign of the 0. So the first factor will be x plus 3. Look, the first 0 was negative 3, so I put it as positive 3. With 2, this next factor is like, who's this person? Like Maria Emma is saying, x minus 2, because the next 0 is positive 2. So I just change the sign. And last but not least, the value of 5. That is another 0. So to find the factor, the other factor is x minus 5. Did you see what we're doing? Take a look at these, guys. Take a look at this. From the exercise, we had the zeros at last. But before we had the zeros, we had the factors. Look, we had the factors. Uy, ¿qué pasó? X, 2x plus 1 squared, and 3x minus 1. These are the factors. So we are, in fact, working backwards. From the zeros, we are getting the factors. And finally, now that we have the factors, all we have to do is multiply them. And we have the function, guys. We have the function. So that is exactly what we're going to do. We just 1 second to get to where we were. Here, right? So we have the 3 factors, x plus 3, x minus 2, and x minus 5. How do we find the function? Just multiply those 3. Boop. There it is. That easy. The function will be x plus 3 multiplied by x minus 3 multiplied by x minus 5. That's it, guys. We are done. That is it. That is it. Now, how do we know? Because look at the question. Look at the question. Find a polynomial function of degree 3. How do we know if this is a degree 3 or not? Well, we are going to have to expand these multiplications. Expand these. How? Doing the distributive property. Let me take a screenshot of this little piece. So this is what I mean by distributive properties. You are going to take the first value, multiply by this, and then multiply by that one. Then this multiplied by this, and this multiplied by that one, right? That is the distributive property. So this is what we have. Let me see if we get it correctly. X squared, right? The first one. Then the second one, x minus 2, so negative 2x, right? Then the ones down, we have 3x, so 3x. And the last value, 3 times negative 2, so negative 6. That is the first distributive property. But now we have to continue with the last one, times x minus 5. I didn't forget about this one, right? It's this one over here. So we do distributive property again. This times this, and times this. Now this, let's do it down. This times this, and this times this. With every single value, this and this, and this, and this, and this, and this, and this, and this. It is going to take a long time, but we can do it. At the end of the day, we should get this solution right there. It is right in the screen, right there. And now we can see that this is, in fact, a polynomial function of degree 3. All right, guys. Okay. All right. So it is now time to practice. Now, we're not going to work on those exercises that you saw. We're not going to work on those exercises. From now on, guys, I want you to please go to alex.com. Alex, log in and get to work on your exercises. Now I think the Alex is open only at 11:30, right? So let me just change the time so that you get more time to practice.
And why you don't give us like a little break, active pause?
Una pausa, Parrado, ¿quieres una pausa?
Una activa.
Ok, pues mira, ¿sabes qué podemos hacer? Mira, yo pongo la actividad y tú pauseas la cantidad de veces que tú quieras. Porque pues es tu trabajo en clase. Tú miras si pauseas mucho o pauseas poquito. Si te levantas y comes un sanduchito o más bien te sientas a trabajar. O sea, no estoy siendo sarcástico o mala persona para nada. No, es en serio, porque es el trabajo de cada uno. Entonces, cada uno, pues bueno, mira qué tan rápido trabaja. De pronto alguien quiere descansar un ratico. Eso está bien. Pero sería injustísimo con todos mandarlos a descansar cuando de pronto alguno no quiere descansar. ¿Ah? ¿Qué tal que Sara no quiere descansar? Mira. ¿Qué tal que Luna no quiere descansar? María Emma. María Emma se ve como que María Emma no quiere descansar, mira. ¿Eh? I'm going to stop the recording now. Thank you guys for listening to my presentation. Remember, if you have any doubts, I am here for you guys.